We are the climate hackers. And we are using AI to predict Brazilian wildfires. The problem, it's a huge one. There were 2,500 fires last year in Brazil. That's a huge number. Now, you might not think that's a lot. That caused over 4.6 million acres of tree loss. That's thousands of football fields, which is crazy, and it's only in 1 year. Now, there's some causes for that. Some of these include dry weather conditions, volcanic eruptions, lightning, and human-triggered fires. That's the biggest one, human-triggered fires. Why should we care? The Amazon is the largest tropical rainforest in the world, producing 20% of the world's oxygen. That's a huge amount. It's almost like the world's lungs. It also contains 30% of the world's species, 390 billion trees, 16,000 plant species, and millions of animals and species that are unique, including jaguars and black panthers. Now, in addition, by the burning of these forest fires, it's actually adding, not taking away from the cause of climate change. This is because when the fire burns, it releases tons of CO2 into the atmosphere, meaning there's more greenhouse gases in the atmosphere. In addition, the trees that burn can no longer take away CO2 because they're dead now.
So now I'm going to talk about our solution. What we wanted to do was find a link between weather data and atmospheric properties and the carbon emissions. So we got a data set from different weather stations all around Brazil, giving a lot of atmospheric properties like temperature and humidity. And then we got another data set which gave us, for all the fires in Brazil, the amount of carbon emissions. And so we want to connect these two. So what we did was find over the years, so we have data from 2003 to 2016, we want to find the distribution of the daily carbon emissions. Why do we want that? Because what is a fire? What is a big fire? That's what we want to predict. There could be a farmer just burning some crops, so we want to find a threshold for the amount of carbon emissions necessary to have a big fire. So therefore we decided to look at the outliers of our distribution, set this as a minimum threshold for the carbon emissions, and then we're going to do a binary classification problem on that. So here you see Brazil again. Another thing what we did was, compared to the data set that we had, we wanted to reduce the size of our carbon emission data to make our model run on our computers and to not have a way to computationally complex models. So we reduced it to a grid of 20 by 20. And so you can see here for I think 2003 in September, these are the carbon emissions, so we can locate where the fires are.
Okay, so it was a mess to join those data sets. Once we finally have the target value that is 0 if it's no fire, 1 if it's fire, we are trying to make some classification tasks based on weather data, and once we have that weather data, which will be the outcome. So we use a light GMB model that is actually a framework for boosting gradient, and actually that's based on decision trees, and with that we can calculate which variables are more important to predict our target variable, that is in this case will be the fire. So you are the most important one is the altitude, month, year, max temperature, average wind speed, and so on. So the first step to make some prediction was taking into account all the variables that we have, and then to make the classification with the most important ones. Okay, so the accuracy of the prediction was 80 to 83%, and the null accuracy was 0.54. And actually, the accuracy is quite good. And actually, the null accuracy is like if you are going to predict only with the most repeat class, which will be the accuracy of doing that. So 0.74 gave us that is a data set that is balanced of which if we have fire or no. So the USC, the bigger the better. So with the measurable reduction was 91, and without the precision was 90. So in the curve, you are seeing that it's a pretty good curve of classification. Okay, so the first, the upper left one is like if we are predicting those that are not fired, and the other one like is like the 29 is like which or those are real fires. So in conclusion, it was a good point to make some dimensional reduction, and for now on we are going to give you, once we have this model trained, what we can do for it.
Now we'll basically try to use our model. So how the model would work is you would fill in, this is the dimensional reduction of parameter space that we have. So for example, you fill in a new year. We only trained from 2003 up to 2016. So we tried a new year, a new month, and then some atmospheric properties at a specific location. So if you run that and then you calculate the new value, the prediction, our model can basically predict that there is going to be 96% probability of having a fire with these conditions. Thank you very much.